Okay, this is for section 8.1 on multiplying and dividing rational expressions. It's usually the idea that they multiply or divide. It's before you add or subtract. We'll get the addition subtraction in the next section. So first thing the author defines is a rational expression. A rational expression is a ratio of two polynomial expressions. And my guess is that you did a little bit of this in Algebra 1 towards the end, but I'm going to figure we're starting from scratch. Okay, on the directions, they're asking basically three questions or directions. They'll ask you to simplify each expression. And then it asks under what conditions is the expression undefined. We'll talk about that in a minute. Under what conditions is the expression undefined? Another way to say that is what values would you exclude what values would you exclude from the domain? Another way to say it is what values would make the denominator? What values would make the denominator equal to 0? Okay. And I'm going to go through some examples. So the examples, say they give you, up in the numerator is 3y squared plus 21y, and it's all over the quantity y plus 7 times the quantity y squared minus 9. And they want you to simplify that. Okay, and one thing, I don't care if you go up or down when you're working it, but there ought to be some equal signs in there. Okay, so on the top part, you want to factor that. What's in common on the top part? 3. What else? Yeah, so you want to take out a 3y, and then out of that first term, what's left inside? You need a y plus 7. Okay, and you should be able to check it. If you multiplied this back, that'd give me 3y squared. That'd give me 21y. And remember, you cannot have anything left in common inside the parentheses. Okay, the bottom, the y plus 7 is factored completely, but the y squared minus 9 is a difference of 2 squares. Factor that. How do you factor the difference of 2 squares? Yeah, 1 plus sign, 1 minus sign. One's got to be a 3 plus 3 minus 3. Okay, so your first thing is to get it factored. Okay, before we simplify it, let's answer the questions up above. Okay, and I said it different ways. They might say under what conditions is the expression undefined. They might say it, what values would you exclude from the domain? What values would make that denominator 0? Those are all asking for the same thing. So you look at this, and what's going to make that equal to 0? -7. So that is a value you would exclude from the domain. X can, or y cannot equal -7. Yep. So those are the values that you exclude from the domain. Those are the values where it would be undefined. Those are the values where the denominator is equal to 0. It all says the same thing. Okay, now you go in and you reduce it. You have to, and I always tell people don't get slash happy when you start marking things out. The only time you can use a slash to reduce, okay, is if it's in terms of multiplying. If this is a time sign in between here, usually I don't put the dot, and there's a time sign in between there, then I can use the slash and reduce. So I can say y plus 7 will reduce with y plus 7, and you've got to remember what's left is a 1, okay? And then, can we reduce anything else? Nope. Okay, so your final answer is 3y over y plus 3 times y minus 3. Now the author might, I would leave it in factored form. I would not multiply that bottom out. Okay, everybody okay on number 1? That's your answer. Yep. Okay, then on number 2, let's say I give you x squared plus 2x minus 3 in the numerator. In the denominator, it's x squared minus 2x minus 15. I want an equal sign in between your steps. Okay? If you're going left and right, there ought to be an equal sign. And then this is going to make you go back and review all the steps in factoring that we did before. From look for what's in common, look for the difference of two squares, look for trinomial squares, look for trinomials, look for the sum and difference of two cubes. All of that is coming. Okay? So on this, anything in common on top? Is there an x in each term on top? No. Nope. So now I go 2 sets of parentheses. Okay? First thing I look at is that sign. That tells me when I multiply them out, I got to get a negative 3. So one's got to be positive, one's got to be negative. Okay? This tells me I need two numbers that multiply together to give me 3. If there's a 1 in front here, the clue is they multiply together to give me 3, and they differ by 2. So 3 and 1, and this is the sign of the larger one. Okay? So this is the sign of, this one's the sign of the larger one. So it's got to be x plus 3 and x minus 1. Right? So that when you ought to be able to foil this back and get the original. If you can't foil it back, even just by sight, and get the original, you know you've got it factored wrong. Okay, the bottom, there's nothing in common. So go to 2 sets of parentheses. I know I need an x and an x. This tells me the signs are different. 1 plus, 1 minus. They multiply together to give you 15. If that's a minus sign, you say they differ by 2. And this is the sign of the larger one.
X plus 5, x minus 2. X minus 5, oh.
Yep.
Oh, yeah, the minus.
This is the sign of the larger one, so the 5's got to be minus. Okay? Okay, now, if they said, what values must you exclude from the domain? 10 and 5. So, what's going to make this equal to 0? What's going to make this equal to 5? Yep. And like up here, they can write those directions. This is one way to write it. This is another way to write that same thing. This is another way to write it. So basically you're just saying, what would make that denominator equal to 0? Okay? Okay, now we can reduce it. We've got it factored. This x plus 3 would reduce with this x plus 3. So final answer, you have x minus 1 over x minus 5. Okay? Okay, now, the next one, they're just going to say simplify. They're not doing the undefined part. So on number 3, in the numerator, it's x to the 4th y minus 2x to the 4th. It's all over 2x to the 3rd minus x to the 3rd y. X to the 4th is in common. What's left? y minus 2. Correct. What's in common on the bottom? X to the third. Mm-mm. 2 minus y. Right? You got to be able to multiply that back to get the original signs. So 2 minus y. Okay, now before we go any further, these two look alike, except the signs are just opposite. If the signs are opposite, out of the little trick to that is out of either one of them, factor out a -1. It does not matter which one you factor it out of. I ended up factoring it out of the bottom. So I'm going to leave the x to the 4th. I could go ahead and reduce it. Let's go ahead and reduce those. Let's go ahead and reduce. So the x to the 3rd and the x to the 4th, when you divide monomials, what do you do with the exponents? So what's left? X on top. So we have an x left on top. So I have x times y minus 2 over 2 minus y. Okay, I'm going to factor the -1 out of the bottom. Okay, so if I factor a -1 out of the bottom, that's going to change both signs inside. Okay, and I don't care if you circle it, use a different color or something. Okay, now these two, this is a y minus 2, this is a positive y minus 2. Now I can reduce them. So this will reduce with this. So I have left x over -1, which is -x. So final answer. So you might write a note here, factor, because I still have a -1 left down here. Okay, factor out a -1 out of either. If the signs are just opposite, factor it out of the top or the bottom. Okay, then we're getting into the actual, that's how you simplify. Now let's look at multiply and divide. So this one is multiply and simplify. Multiply and simplify first, then we'll divide. So problem number 4. If I have in the numerator 8x over 21y cubed times 7y squared over 16x cubed. On this one, I would actually simplify it before I multiply it. And if it's a time sign, it's got to be where one's in the numerator, one's in the denominator. You can reduce. So, like I could reduce this 7 with this 21. 7 would go into 21 3 times. I could reduce this 8 with the 16. I could reduce the x's, an x to the first divided by an x to the third. Where at? No. Yeah, it's on the bottom, right? Because you have an x to the second one. Think about this. If you have an x to the first over an x to the third, if you ever get stuck on that, write it out the long way and reduce it. You get 1 over x squared, right? Okay. So, are they doing negative exponents? No. No. What about the y's? Y on the bottom. The larger exponent's on the bottom, so that part of my answer is on the bottom. So, what do I have left on top? Over. I'm multiplying 6 x squared y. Usually they will write it alphabetical. So 1 divided by 6 x squared y. Okay. Is that enough time?
So wait a minute. What is the x1 to the x squared over there? What are you guys showing?
I'm just showing how to simplify this much of the problem. That's the long way. If you ever forget, does the x squared go up on top or does it go on the bottom? Yeah. But if you didn't remember, write it out the long way. You can always write it the long way. Because these would divide out and you'd have a 1 over x squared.
Where's the 1?
When you reduce all these, multiply 1 times 1 times 1 times 1. So you still have a 1 up on top. Okay? Yeah, you got to remember when you do those slash marks, you're just reducing. Okay. Okay, number 5. Up on top is a negative 10, x to the third, y to the second. In the numerator is 9, x, y to the fourth, times. This one up in the numerator is 3y. Down in the denominator is 25x. Okay, so if we reduce this, the order that you reduce it doesn't have to be like mine, but your final answer should be the same. I could reduce the 3, and 3 goes into 9 3 times. Yes, I'm doing it one at a time. Okay, then I could reduce the 10 and the 25. I could say 5 goes in here, and I could go 5 in here. The x, I have an x squared on the bottom, x times x. I could do those individually or together. I have an x squared and an x to the third on top, so those would go out, and there's an x left. I have a y to the second and a y to the first. That's a y cubed. So I could take a y cubed out, and I'd have a y left on the bottom, right? So I have a negative 2x left. And if you want to, you can circle them if that helps you see it. And I have a 3 and a 5. So that'd be a 15 and a y left. So, how many got that right? Ooh. Did you find your error? Did you find the error?
No.
I didn't know you were like cross.
Up and above. No, you can go from a numerator to denominator, up above, or as long as it's times, you can reduce. Okay.
So how do you get down to just one x?
Okay, so you've got an x to the third on top, and then in one of them you got an x here and you got an x here. So x times x would be x squared, and then x to the third divided by x squared, you have an x left. You can do it one at a time. I could do this. I could say this goes, and I'd have an x squared left. And then this goes, and I'd have an x left. You can do them one at a time, but you can also do them together. Okay?
I can just do it.
Yeah. Okay? Good. It's your choice. Okay. Then on the next part, they're going to change it to division. And it's basically divide and simplify. And it has to be in the simplest form. Same thing on the homework, or I'll count it wrong. Okay, on the first one, up in the numerator is 10xy squared. It's all over 3c squared d divided by, there's a little division symbol, up in the numerator 5xy over 6c squared d squared. The only difference on division, when you divide rational expressions or fractions, you invert the second fraction. You've got to turn it upside down. So rewrite it. The first fraction stays the same. Times. So then we have, you invert and multiply. So you change that to a times sign. And up in the numerator we have 6c squared d squared over 5xy. Okay, so if I'm reducing this, I can reduce the 5 and the 10. I can reduce the 3 and the 6. So I have that left. I can reduce the x's divide out. I have a y and a y squared. What's that? I have a y left. The c squareds, don't say they cancel. Cancel in math means subtraction. Say they reduce, they either reduce or they divide out. Okay, and these will reduce. Okay, I have left on top 4dy or 4yd. I don't care the order. The 4 needs to be in front. Okay, and on the bottom, just 1, right? So that's your answer. How many got it right? Yes. Alright. Okay, last example. So remember, you got to look for that division sign. Division, you invert and multiply. Okay, then last one, we're going back to just simplify. Okay, up in the numerator, they have x squared plus 2x minus 8. So we're back to a polynomial. And the key on this is you're going to factor, star that, highlight it. Up down in the denominator is x squared plus 4x plus 3. Okay, now instead of just simplifying, now they're going to simplify and multiply. So up in the numerator over here is 3x plus 3, and the denominator is x minus 2. Okay, so first thing, we look at this. Is there anything in common? No. So then you're going to go to two sets of parentheses. Factor it. Signs have to be different. Two numbers that multiply together give you 8 and differ by 2. 4 and 2, and this is the sign of the larger one. So the 4's got to go with the plus, 2's got to go with the minus. Nothing in common on the bottom. So factor. Signs are the same, and this tells you they're alike. This tells you they're definitely both positive. Multiply together to give you 3, and if that's a plus sign, you say they add together to give you 4. 3 and 1. What's in common on top? What's in common? There's a 3 in common on top. What's left inside the parentheses? X plus 1. This one stays the same. Okay, now you can reduce. Can you reduce anything? Yes. These two quantities are alike, so those can reduce. The x plus 1s are alike, those will divide out. That's it. You cannot take the 3's out because this one is in a quantity. Okay, so multiply on top, you got 3 times the quantity x plus 4. On the bottom, you just have an x plus 3. The author might multiply that out. So if you leave it in factored form, I'm okay with that. He might also write it 3x plus 12 over x plus 3. You cannot reduce the 3's on that. You can't reduce the 3 and the 12. You cannot put slash marks around a plus or minus sign. It has to be in terms of multiplication. Okay, I'll give you time.